spot on the shill list. You obviously are a excellent fucking researcher, let me tell you. Um, let's see here. Okay, so I've said this, you've heard me say it a million times before. But if we get real close up here, and I'm going to get a smaller brush. Can't see. Get out of here. Okay, so just follow me because I think this is something people can work on or whatever, because it's certainly not been answered to my contentness yet. So if we've got a person standing here and they're measuring 1 mile to the next person, they say this is 8 inches of curvature. Okay, something I think everybody agrees on. And if we measured from this person to this person, and this is another mile, and it's just measuring here, well, that would also be 8 inches. I don't think anybody can argue with that. And if we added a third person, this person to this person, also going to measure 8 inches. Okay. But they tell us that if you measure this guy to here, that it is 8 inches times the distance squared. So 8 inches times 3 times 3, which is 9. So 8 times 9 is 72. Okay. So can somebody explain to me how if in this first mile, we're going a mile out, 8 inches down. Second mile, mile out, 8 inches down. Third mile out, 8 inches down. That's 8, 16, 24 inches of drop. 1, 2, 3 times 8 is 24 inches of drop. So how can somebody say it's 72 inches? How did we drop 72 inches? Doesn't make any sense at all. There's no way you can get from here to here and drop 72 inches. So everyone can get all upset and go crazy and flip out and, oh God, you're going against math rules, and don't you understand how exponential works, and don't you, yeah, go ahead and say all you want. It's, in my opinion, it's a deception. And let me explain to you why. Because a circle is constant. It's a constant change, constantly. Okay, so if it's 8 inches, then it's 8 inches every single mile. The circle never changes. Doesn't matter if you're measuring here. I understand exponential if you're talking about, okay, we're measuring from here, and let's say we're measuring to here. Well, obviously, the curvature here is going to be much less than when you get to here, because this is almost a straight drop down. Okay. But the way that they treat the ball is, technically speaking, you can just take this ball, spin it right like this, and that actual change here should be 8 inches. They say there's no up and down in space, all that fun stuff, right? So if that's the case, then, whoops, give me this black here. Okay, so let me just back this up. So if you ask me, and I've said this many times before, I still am sticking to it because I don't see any problem with it, that if we've got a total circumference of the Earth of 24,901, wrong color, sorry. Okay, so we've 3. Okay, so we've got 24,901 is the circumference, and you multiply that by 0.318, which is the, well, we can do it the other way if you want, but we know that the radius of Earth is 3959. And I think that the diameter is 70. I don't remember this offhand. 7918 or 19, something like that. Okay, so again, follow me along here. If somebody's walking from 12 o'clock, okay, to 6 o'clock, they're walking this distance, okay? How much curvature did they go over? Okay, to me, I think it's easily described as the curvature between 12 and 6 is this. It's your radius. Okay, this is the curvature that you went over. Another way of looking at that, I had a engineer tell me that if you draw a chord like this, that this is the curvature. Oops. That's the curvature. If you draw a chord like this, then this is the curvature. Okay. In fact, if you wanted to know the curvature of the whole ball, you could technically get way up here, draw a line from here to here, and the curvature is this. Okay. So knowing that, that means that if you travel from 12 to 6, that your curvature is the radius. And if you finished your way all the way back up, well, your curvature is the diameter. So in my opinion, the curvature of every circle is its diameter. Okay, so if that means that our curvature is 7918. Okay, and if that's the case, then you just take 7918 divided by the circumference, 24901, and you'll get 0.318. Okay, and there goes that number again, my favorite number, because I think it's hidden for a reason. 0.318. This is how ridiculous I think the globe is. I think that the curvature of the globe is 0.318 miles per mile. Okay, so if we want to figure out what that is, take your 0.318 times 5280. And this is how dumb I think we humans are. I think that the curvature per mile is 1,679 feet per mile. That's what it would take. You need to go a mile out, 1,679. Mile out, 1,679. That's the only way you can get all the way back up in 24,901 miles. So I think that the 8 inches per mile squared is a complete and total joke. I think it's manufactured based on our eyesight, so that, because they say it only works, first of all, to like a quarter of the globe, which we have math equations that work for everything else in the world except for figuring out the curvature of a ball. And it doesn't matter what distance this is. We can make up any number. Let's say that this is, let's say it's 50,000 feet. Okay, 50,000 feet. And if you do the math again, you can multiply by 0.318. People probably don't like that, but too bad. So if you go 50,000 times 0.318, and you'll see in a second here, that's 15,900. Actually, let's look at let me see real quick what the sun is. So sun, circumference. Make sure we're getting the right numbers here. So the sun circumference, we'll do this one because it sounds like fun. 2,713,406 miles. And its diameter should be 8,999 or something like that. 864,575. Okay, so we'll go do this. So, where's my thing? Here. All right, so we're going to do the sun instead, since it's a red ball. Okay, so the circumference of the sun is 2,713,406. And that's the circumference. And again, you don't need to tell me that, well, that's not how we were taught in school, because it doesn't matter to me. We're using our head, and you can tell me where I'm doing it wrong. Okay, so the circumference is 2.7 million. And the, shoot, why didn't I write that down? Diameter is 864,575. 864,575. Okay, so 864,575 is the diameter. So we now know the diameter is 864,575. 575. Okay, so to me, this is what they're hiding, is the diameter is the curvature. Okay, because again, we can go here and do the radius. And the radius is going to be 432 or 431, whatever half of this is, 864,575. And we know that that's going to be divided by 2. So 432, 287 is going to be the radius here. So if we walked from the top of the sun to the bottom, we went over 432, 287, walked back the other way up, 432, 287 for a total of 864, 575. So if we take this and divide it back by the number, anybody want to guess what it would be? Does anybody have any good answer? What do you think this number is? 864, 575 divided by 2,713,406. Anybody going once, going twice? Well, what do you know? It's 0.318. And it always will be, because it doesn't matter. You're talking about a circle. The curvature of a circle is 0.318 blank per blank, meaning it doesn't matter what we're doing. This time we're doing miles. So we're curving 0.318 miles per mile. It's going to take you doing that kind of turn per mile to come all the way back around. And it doesn't matter if it's feet. If this is 2 million feet, well, then it's 0.18 feet per foot. You can do it that way. It could be meters per meter. Basically, a circle is this number here. And this is why we never hear about it, because it is the reciprocal of pi. 3.14 divided by 1, divided by 1 is 0.318. So 3.1415269, that whole thing, divided by 1 equal, it's the wrong way. 1 divided by 3.14 equals 0.318. So again, and you can go online and look this up. Why is it that if you look up online right now, how do I get the diameter or the circumference? How do I get the diameter or the radius if I have the circumference? They will tell you to go through a whole bunch of steps, but what they won't tell you is to multiply this number by 0.318. That's what we should have learned in school. Take the circumference times 0.318 equals the diameter. And then you can just cut that in half to get radius. And again, we can go watch a video real quick. Look up on YouTube, and we'll just type in circumference of a circle, or diameter if we know the radius. So diameter with known radius should be simple. Times it by 0.318. Let's see what we saw here. Screen sharing, stop. And we're going to go back to here. Screen share. And we should be over here. Present everyone. All right, so hopefully you can see my screen there. I don't know if you can. Diameter with known radius. We'll just see one of these. Introductory to circles. We can go with that one. Get out of here. I don't know if you can hear this or not.
A circle is a perfectly flat, round shape. You can draw a circle using a compass. This is a different kind of compass than the one you use to find north. A geometric compass is shaped like a V, which can be opened or closed, and one end has pencil lead for drawing. Simply open the compass until you find the radius you desire.
Nope, that's not one that tells us how to get the answer. So let's see. Class 4 and 5, all about circles, radius and diameter. I'm trying to find one that tells us how to get it. Finding the unknown radius or diameter length of a circle. See what this one says?
What? Still searching YouTube for math help? Are the videos from 2006 really helping? Aren't you?
Sometimes you may be asked to figure out what
okay, so here he says circumference equals 47.1. 47.1 times 0.318 equals 14.9778.
To figure out what the length of the diameter is, we can start by writing the formula to find the circumference of a circle, which we know is c is equal to pi times diameter.
And we can just take this divided by 2
we can solve
to get the radius.
d, or the diameter.
7.4889.
First, we start by taking the value 47.1 and substituting it with the letter c in our equation. Because c stands for the circumference and we know what the circumference is, we simply plug that in for c into our
So he's going through a bunch of other stuff.
And we know the value of pi is 3.14, so next we are going to substitute 3.14 in for the symbol of pi in our equation. And that just leaves us with the variable d. Now what we are going to do is isolate the d variable so we can figure out what it is equal to.
This is dumbing kids down.
Notice that we have 3.14 times d on the right-hand side of our equation. So to isolate the variable,
just multiply by 0.318.
Opposite of multiplying d by 3.14, which is to divide by 3.14. So we divide 3.14 by itself.
Just multiply by 0.318.
And we also do it on the other side of our equal sign so we can balance our equation. Because 3.14 cancels out on the right-hand side of our equation, that leaves us with d all alone on the right-hand side. And on the left side, we have 47.1 divided by 3.14. After we take 47.1 and divide it by 3.14,
so they could have saved people 3 minutes of their life.
The diameter is. So I'm going to take 47.1 and divide it by 3.14.
14.9778.
To have a decimal inside your divisor, you have to turn that into a whole number. And you do this by simply moving the decimal all the way to the end of that number. So we have to jump over 2 place values to move that decimal all the way to the right.
This is nonsense.
The inside what you did to the outside of your division problem. So on the inside, we are going to move this decimal 2 places to the right.
See, I should teach math classes.
And after moving it in equal number of place values, you should move it directly above in the problem. 314 can be divided into 471 one time. 1 times 314 is 314. Next, we subtract 314 from 471, which gives us a difference of 157. But we still have a place value not accounted for, so we take that 0 and drop it down, and now we have 1,570. Dividing 314 into 1570, that can fit into 1570 5 times. 5 times 314 is exactly 1,570, leaving us with no remainder. So we have figured out that the diameter of this given circle is equal to 15 inches.
Now it's 14.9778.
Now let's do an example when you are asked to find the unknown radius of a given circle.
Okay, so 25.2.
This time we are going to use the equation circumference is equal
times 0.318. And actually 318 has a bunch more numbers at the end. That's why it's kind of slightly off. Equals 8.01 divided by 2 equals 4. So the radius is 4.
It is given in the problem that the circumference is 25.12 meters.
Let's get over here to where he tells us the actual answer. There you go,
exactly 4 times, leaving us with no remainder.
So anyway, basically what I'm showing there is, oops, I don't know if I screwed that up. Great, what did I do? Oh yeah, this one. Okay, so as I was saying, oops. This is something that should be known, but it seems to me that until somebody tells me differently, I've had engineers say that this is the curvature of that chord. So if this is the curvature of that chord, then this is the curvature of this chord, which means the curvature of half a circle is its radius, meaning the curvature of a whole circle is always its diameter. So to me, it just seems like the curvature of a circle is its diameter. And anytime you take the diameter and you you divide by the circumference, you're going to get 0.318. And that's because it doesn't matter. Even even if this circle is a mile, it's just 1 mile circumference, then that means its diameter is 0.318, which means its curvature is 0.318 miles per mile. So you'd have to break it down into feet, but it's the same thing. You're going basically 0.318 to get this whole mile. You're going to have to curve that much to get back to where you started. So whether it's 10 miles, 11 miles, 111 miles, 1111 miles, 71, doesn't matter. It's 0.318 miles per mile to get back to where you started. So I still sticking to that. I could be completely wrong. I'm not saying that I'm right. It just seems like it makes sense to me. And any kind of 8 inches per mile squared doesn't make any sense. As I showed you before, it can't be 8 inches, because how can you say that if we lined up 24,901 people, okay, so we all get around the earth and we stand 24,901 all the way around, all the way back to here. Here's all these people. And each of them is measuring 8 inches between each other. 8 inches, 8 inches, 8 inches, 8 inches. Well, that's only 8 inches times 24,901 equals divided by 12 equals divided by 5280. Shoot. 5820, whatever. Now it comes out to about 3 miles of total curvature. So if anybody believes that you can start at 12 o'clock, go 24,901 miles to come back to where you started, and your curvature was 3.7 miles or something, no way. Yet they say it's exponential, but it's not exponential, because if this person is measuring 8 inches between them, then these two measure 8, then these two measure 8, and these two, and these two, and these two, and so on and so forth. It's constant. So where's the constant curvature? Where's the number that tells us how much it should curve? I wouldn't be surprised if in 1 mile we're supposed to be curving 1,600 feet, because that makes more sense to me with living on a ball. Certainly not, oh, it's so big that you can't see the curvature, but you can see that boat go over the edge right there 3 miles away from you. Makes no sense. So I'm going to check the chat here one more time, and then I'm going to go visit my wife in bed. Oh, here we go. Okay, so who you? I can't believe I have to do this again. You're kidding me. Learn spherical geometry. Pay attention for me here. Watch for me for a second, because I don't think anybody gets it, and you want to scream that what you were taught in school is correct and not pay attention to what's right in front of you. It's like, can't help you. I really cannot. But I'll try it one more time, and you tell me what I'm missing here, because, oopsie, that didn't work well. Okay, this is for who you. Where is he? Where's who you? Oh, I saw you. Dude, I lost you. Hold on. I can't keep up with the chat. 1 second. I gotta see what you said last time. Ah, shit. What did I do? Damn it. Hold on. What happened here? Ah, shit. I lost him. Trying to find you. Where did he go? Bless it. Oh, jerenism 8 inch. Okay, saw that one. And then let's see what you say next. Dude, I'm a flat earther. I don't think you get it, bro. Okay, so I'm going to show you something, and you tell me what I'm doing wrong. Because you said it's 8 inches per mile squared, which I know that. So I'll show you again, because you weren't watching me or something. Okay, so watch me and tell me what I'm doing wrong. This is for who you, please. This circle, okay, it's 8 inches per mile squared. I understand that. But if you're measuring each distance, so if in the first mile, this person to this person measures 8 inches, Okay. Then from this person to this person, the next 8 inches is also, the next mile is also 8 inches. And if you say this is incorrect, then that's impossible. You're saying that in the first mile, it's always 8 inches. So in this mile, forget this guy. We're just talking these two. It's 8 inches. And this guy, from here to here, it's 8 inches. Okay? I said, I understand that. But you're saying we have to measure from this top guy, right? Okay, so tell me how we went from here to here. Okay, we went down 3 miles. So 8 inches times the distance squared, which is 9, is 8 times 9 is 72. Okay, so 72 inches, but we just dropped 8 inches, 8 inches, and 8 inches. So we dropped 24 inches in those 3 miles. You're saying, no, it's exponential. You have to, it's squared. Okay, why? Why? This seems like an excuse to make it so that as you start to get to about as far as you can measure or see, now it's the curvature is big. Because they don't want to tell you that the curvature of a circle is huge. Every mile you went would have to be equal. It can't be exponential because there's no up and down in space. So you should have to, it should be the same everywhere. Where do you see this circle that has a different curvature? It's the same everywhere. No matter where you're at, it's the same curve. Same thing. Same thing. So this makes no sense. Doesn't matter 8 inches per mile squared. You can't figure that out. It doesn't make any sense. It can't start growing in curvature. The curvature of the circle is constant. Constant. Okay, I'm looking back. What do you say now? Oh, Jed, you just are proving yourself to me. Thank you. Where is hey you or hey now or whatever your name was? I'm waiting for you to tell me what I did wrong. Okay, so I see that Nicholas said I forgot the angle where I started from. But what I'm saying is, so you're saying there's an angle here. But if we're talking drop, okay, so we went out a mile and dropped 8 inches. And went out a mile and dropped 8 inches. And went out a mile and dropped 8 inches. So I don't know what angle you're talking about. This one? How can the angle drop lower? You're saying that the angle went like this. Because we went 3 times this. So how did we only dropped 8 inches 3 times. So how can it be 72 inches? What kind of crazy world do people think we live in to where shit like this happens? I don't get it. Doesn't make any sense to me. Let's see if I miss somebody. Okay, so I like Christian. Tell me this. Isn't there a mistake, Christian, in the fact that there's no formula for the curvature of a perfect circle? Christian, how is it an approximation? Tell me, we've got a formula for everything else in the world. Everything mathematically has a formula, but not the curvature of a perfect circle? That would be constant curvature? You guys are fighting your own education. You're just fighting it. You're holding on to whatever you were taught. You're just holding on to it because you can't open your mind to something new, to the fact that, think of a circle. A circle has equal curvature everywhere. There is nowhere, you don't have to exponentially change it. You don't have to multiply it by something squared. It's a circle. No matter where you're at on the circle is the same curvature between you and the next mile, between another mile somewhere else. So if they're telling us the first mile is 8 inches, then we need to realize that they're telling us that because there's no curvature. There's no curve. So they said, tell them it's 8 inches in the first mile, since they'll never be able to measure that. And then it goes to 8 times 2 times 2, which is 32 inches in 2 miles. They'll never be able to measure that. And before you know it, by 10 miles, the number's outrageous, but it's nowhere that we can measure. So who you? You want to call me? Jump on the phone. I'll open the thing back up if I can get back in. Nobody else call, please. Let So Who You call me. I would love to hear where I'm getting this wrong. He says he can easily explain it to me. 1 second. Let me get back in here. And excuse me. Okay, so numbers. Jeez. 562-735 flat or 562-735-3528. Hopefully it's So Who You. Don't worry, I won't give out anybody your phone number or anything. I'm waiting. Did I? Yeah. Okay, I think it's open. Oops. Still in the drawing. Is So Who You calling me? I haven't seen anything yet. Jed Skeptic, nobody's even paying attention to you. I'm dealing with somebody else. You already think I'm a shill. What difference does it make? Ah, somebody banned you. Look at that. Type the number in chat. Okay. Yellow.
Yo, damn, man, that was a lot of noise in the background. Look, all right, so look, this is what I'm
Hold on
gonna
one
tell
second.
you.
Hold on one second. That's like
Go on
hold on,
Google
hold
real
on,
quick.
hold on, because that's like way too loud for me. Hold on.
Oh, my
There.
bad.
No,
I'm on a shitty ass Obama phone, so you know.
All right, go ahead.
All right, so look, go on Google real quick and type in 8 inches per mile squared, and then click on images.
So go on Google. You mean you're going to show me the
Yeah, you know the map, the little drawing diagram that shows 8 inches per mile shit, right?
Yeah, you mean the
right.
one from AutoCAD.
All right, so what you're doing right now, you're calculating the curve, but what you're doing is you're doing it per mile. You're measuring that distance, that downslope. What you need to do, the reason why it's square is because you see the little line that goes, it does a little right angle line right there.
So you're talking about the tangent line. You mean like this line?
Exactly. So that 8 inches, they're not calculating the curve that's on every single inch. They're talking about that line, the distance between that line and the ground.
Okay. So
that line between that line and the ground, that would be, the 8, the 32, the 70, whatever the hell, and all that crap. It keeps going up from that line.
Okay, but if we went in this first mile, it's 8 inches down.
Right.
Okay. In this next mile, if we're not measuring this tangent anymore, okay, let's just say we're just measuring this right now, 8 inches would be 8 inches, right? And this third mile would be 8 inches. So what I'm saying is you've only dropped 24 inches. So how is this line mean 72?
I am kind of watching the video, dude. It's a little bit delayed, actually.
Yeah. And, I was talking to some guy about this the other night, and he said, well, because you're not changing your tangent. He said, now when you go here, this tangent would, and I said, then it's always the same. If it's 8 inches per mile, then every tangent is the same. It would go this way all the way around.
Well, yeah, but I'm a flat earther, trust me. I'm not arguing about the shape of the earth and all that crap. I already know the earth's flat, but
no, I
think see what you're doing though right there, because like I see how you put in all those little lines right there and everything.
Okay.
You're not supposed to measure from all those little lines. You're supposed to have that one first line that you drew at the very top that you first said the 8 miles or whatever.
Right.
Draw that one completely flat all the way across, and then every single mile you're going to measure from the ground up to that line.
Okay.
And that's where you're getting your exponentially greater distance from. I don't know the exact words. I'm pretty fucking sleepy, to be honest.
Right. No, me too. I woke up at 5 to watch a stupid spacewalk. No, I totally get what you're saying, and it would make sense to me if what I'm showing wasn't the case, which is in 3 miles they say it's 72 inches of drop. Okay.
Right.
But if we just measured from person 1 to person 2, we already know that's 8 inches. They admit that 8 inches, right? So,
right.
But then if we moved and just did from person 2 to person 3 and measured between them, well, they say it's 8 inches per mile squared, but we're just measuring.
Exactly.
But we're just measuring
you're only
1 mile.
Every time you measure from each mile to each mile, you're only going to get 8 inches anyway. I mean,
see, that's a problem.
Even if that's detectable, which it's not because it's always flat. So I mean,
well, that's the point. Is what I'm saying is that they've told us something that is not true in reality. If we measured from every person to person, if we had 24,901 people on the globe from North Pole wrapping around to North Pole, and they each measured 8 inches between them, then the total curvature of the ball is 3 miles. That's ridiculous. It's a joke. It's not. It's. I think.
All right, no, maybe I just jumped into what you were talking about way too late or something like that because I completely agree with you on the whole flat earth thing, man. I've been down with this shit for like 3-4 years now, something like that. But the way I seen you explaining and everything like that and everything, and you were talking about how you didn't get it, I'm like, what the hell is he even talking about? So that's why I was kind of going off, and I was trying to look for an answer on somebody who replied to what I was saying and everything. But
well, here's what I'm saying is that, and I see what you mean by this line's not straight, but what I'm starting to think is that the idea of 8 inches per mile squared sounds like it is an equation meant to, like, for instance, how do we get that equation? Where is the math involved in that equation? Because I don't think it's based off of a 24,901 mile circle. Because what they're basically saying is that from here, it's going to exponentially grow, which I understand that because if we took, for instance, this curvature here is huge. You're dropping almost straight down, right? But it's a circle. And this is why I think people are forgetting. A circle means it's equal everywhere. So
I know from my point of view, when I do programming and stuff like that, I'm drawing spheres and everything like that, and you can only do a quarter of a triangle at a time when you're drawing a sphere, and it's all basically done by the same type of formula.
But then you do the opposite.
Exact thing off the top of my head, but you can only do 1/4 at a time, and every single time you do that 1/4, then you have to rotate that entire thing another quarter, and then you can do the other quarter and everything like that.
Right, and I understand that because that's like if you do this. Oops, it should be clear. Hold on. So if you do something like this, and I know you can only measure this half of the triangle, and then you have to know that the other triangle is equal to it, right? Is that what you mean? I don't know if you can see.
Yeah, pretty much. Yeah, you have to basically measure off from that first point, and then you're doing your line, blah 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 blah, going off that line, and that's where they're getting that 8 inches per mile squared. Supposedly, where they're getting it from is from that top line right there, going back down to the earth every single mile. So every single mile, they're measuring back up to that line up above.
But do you agree that if it's a perfect circle, right? And we want to figure out.
Yeah, if it is, which I mean it's flat. But
okay, let's say that we are talking about a racetrack. Okay, and here's our starting line, our flag or whatever, and we're measuring this racetrack, and we want to know what the curvature is of the racetrack. That it should be constant, meaning it doesn't have. There's no more curve here than there is here, or here, or here. That the curvature.
Well, yeah, I mean, if you're measuring exactly on the curve, but I mean, if you're using the formula, how they're explaining that, because that formula is being explained using that, like on that chart. The reason why they got the 8 inches per mile square is because they're measuring from that starting line. So every single mile from that line back down to the earth is supposedly supposed to be 8 inches per mile square.
Okay,
which that makes sense on that chart and everything, but if you actually measure shit in life, it ain't like that.
And it kind of makes sense, but again, if you only went down 8 inches in each of those first 3 miles, then I don't really see how you dropped 72. But more importantly would be if we lined up 24,901 people a mile away from each other, all the way from the North Pole back to the North Pole, what would be the curvature between each person? Because that should be the curvature of 1 mile, not 8
well, I mean,
inches.
it probably would never actually be there anyway, because you'd probably end up in like edge of South Africa or something, whatever the shit, because you're not going to end up back in a circle. Doesn't mean, we know that the fucking earth is flat. So
yeah, I totally get you.
Yeah, I didn't try to. I wasn't trying to spam you out.
No, that's cool.
Like that,
Hey, here's the thing.
I swear, I probably just jumped what you were saying. I took what you were saying out of context a little bit, but
Well, the thing for me is that I don't want to be wrong. So if I'm, that's why I'm open to, if anybody's got the answer of how I'm not, tell me, because I think what is ultimately happening is everyone is falling for a deception we were taught in school. This is the way that math is. It has to be done.
110%.
Yeah.
I mean, you see it in a lot of TV shows and everything like that. They're doing all kinds of little brainwashing tactics and shit, getting us ready for something, man. I mean, you look at a lot of these shows, you hear the chants and everything that are going on, and like all these little soap operas and everything like crap. You can see the little chants. It sounds like soldiers are marching and shit. They're preparing us for something. I don't know what it is, but they're preparing us for something.
No, I agree. I mean, if anybody out there has got the answer, it just doesn't make sense to me because a circle is constant curvature. And so I would think that we could line up 24,901 people a mile away from each other, and there should be a number that is the curvature between each person, and it's not 8 inches. And if it's not 8 inches, then why are we allowing them to say the first mile in any kind of measurement is 8 inches? Because we should be able to take whatever that first mile is and multiply it 24,901, and that should be the full curvature of the globe, because each mile of curvature is the same. It's the whole way around. And I think it's an outrageous number. I really think that on a globe, 24,901 miles, that if you were to come all the way back to where you started, that it would be crazy. And what did I say? 1,600 feet. That doesn't surprise me. I think that in a mile, that's how much the earth should drop if you're going to come all the way back around, at least in my opinion. So, I mean, I could be wrong, but again, I just think it's more semantics, it's more confusion, and it certainly doesn't seem like reality to me. But who knows?
Yeah. Well,
I
hey, I'm gonna let
call.
you go, man. Let you finish up doing your thing and everything. I got my own stuff I got to take care of here tonight too. So, man.
All right. Thanks
if
for
you ever
calling.
want to chit chat or anything like that, man, hit me up. I got I can be pretty good with math and all that crap. So I technical and other streaming and all that crap too. I do streams and shit like that. I ain't gonna advertise any shit, but
Okay. Well, you can
all right, man.
plug yourself if you want, and you got your phone number, so that's cool.
All right, man.
Later. Take it easy. So I'll leave it open if anybody thinks they've got that answer, but I'll show you one thing to kind of explain what I'm talking about here. Let's say that this, here, this white line, hopefully you can see that white line, which is about 1,600 pixels across. Actually, we'll go the whole thing. Whoopsie. Just so I can show you what I'm saying here. So if we take this whole line, which we now know to be, 1,600, and let's see, if we take 5280, which is a mile, and we divide by 1,600 pixels. Okay, so it's going to be 3.3. Sorry, don't do that. Okay, so we got 3.3 miles per pixel. Okay. So it's 3.3 miles per pixel. So what people don't realize is that we just drew 1,601 across this big line here. Okay. All the way across there is 1 mile. Okay. And it's, oops, I did this wrong. Sorry, my bad. It's, we did 5280, so it's 3.3 feet per pixel. Okay. So a pixel is that little tiny bit. We can't even get close enough. Let's see what a pixel is. This is a pixel, this red mark, 1 pixel, okay, and 3.3 feet per pixel. So that's 3.3 feet. So if this is a mile, this is the drop, is less than a pixel, okay, because it's 8 inches. So is this what you believe? Is this what you think? You're going to let people tell you that on this whole line, this is a pixel? That's the drop that the Earth has on 1 mile. 1 mile across the top here, that little red pixel, and it's less than that. I just can't draw less than that. I can't draw 8 inches. It's 3.3 feet per pixel. So it'd be a third of this. A third of that little dot is how much it drops in a mile. Do you really think that's the Earth? That you go a whole mile and you drop that little pixel, and then the next mile, a little pixel? No fucking way. No way. Hey, Zach Hazel, do you know that you're not being forced to watch this? Maybe you didn't realize that. I don't know if people knew that. I didn't know I needed to announce that. It's not mandatory to watch this. Didn't know if you didn't know that. You're actually allowed to go watch whatever you want. Didn't know if you knew that. Sandman, you're a good man. Demand answers. Am I having doubts about what? Don't get any of this. Martin, whoever's forcing you is doing it wrongly. All right. Well, guys, it was fun. Hopefully you got something out of this. I didn't really, but video should be coming out soon. And then, yeah, like I said, I think next week the shows will start on Thursday. So, and I'm not sure what time they're going to be yet, but it'll be fun. All right. No more calls. So I'm dropping this out. All right, guys, be kind to each other. Don't lie and open your mind. There's truth inside. Believe me. But don't trust me. Talk to you guys soon. It's been jerenism. Peace.